minutes Q&A.
Hello everyone, we are OASE Lab. My name is Yilin Cai from National Universities of Tainan. And over here are my team members.
Hello, my name is Wenkai Guan.
Hello, my name is Zhonghan Zhou.
Here is online. The presentation is divided into the 5 parts. So the first, here is our two-stage system structure. The stage 1 presents the human and smart machine co-learning on gain of goal. The stage 2 is our fuzzy machine learning mechanism and interacts with the robot IBA. In the stage 2, first, we train the dataset based on machine learning mechanism. Then, the message delivery method of AI-FML agents through the MQTT protocol. Finally, students in the classroom are able to interact with the robot. Here is our system structures of precision agent and the cognition agent. In these competitions, we adopt Google AlphaGo Master 60 games to be the training datasets and the testing datasets. We have 6 input variables and a single output for fuzzy inference systems. There are 3 criteria utilized for data pre-processing in this competition. This page shows a pre-processing method for the GAN dataset. This page shows the structures of AMPs for AI-FML agents on the robotic GAN application. We adopt the patch learning-based AI-FML agents with 3 patches. This page shows a part of before learning fuzzy markup language. The right side is role-based, and the left side is knowledge-based. Here we can see the before learning fuzzy sets of the fuzzy variables, and the next is after learning fuzzy sets. This is our 5-layer fuzzy inference mechanism. And the graphic here illustrates AIoT applications of AI-FML agents. And the next is our experimental result. This table shows the loss value before learning and after learning's 2000 epochs. In the experimental 2, we adopt patch learning mechanisms with 3 patches. According to this chart, we can find that the proposed agents of the patch learning mechanism has a decreasing tendency. This chart illustrates mean square error and difference in mean square errors of each GAN. This page shows the regression analysis for GAN 39 and GAN 58. This page shows the scenarios that students co-learning with IBA, Y, UNWA broccoli, and AI-FML agents for GAN applications. Finally is our conclusion. In this chart, we can find that the mean square error has a decreasing tendency when the patch learning mechanisms is implemented in experiment 2.2. Children are all happy to interact with the robots to learn the knowledges of AI. And the next part, we will demonstrate robotic GAN of Go real-world application. Thanks you for listening.
We are going to show the Go application demonstration.
We will predict the win rate of black.
Okay, let's get started.
Welcome to IFML Agent Robotic Go Prediction System. Please touch my belly to turn on the prediction system. To predict the win rate of white, please touch my left hand. To predict the win rate of black, please touch my right hand. Now, let us predict the win rate of black. What is the dark forest simulation number of black?
0.27.
The dark forest simulation number of black is 0.27. What is the dark forest simulation number of white?
0.6.
The dark forest simulation number of white is 0.6. What is the dark forest win rate of black?
0.68.
The dark forest win rate of black is 0.6. What is the dark forest win rate of white?
0.3.
The dark forest win rate of white is 0.3. What is the dark forest top move matching rate of black?
0.72.
The dark forest top move matching rate of black is 0.72. What is the dark forest top move matching rates of white?
0.79.
The dark forest top move matching rate of white is 0.79. Relationship for step 1. Black has an obvious advantage according to the dark forest cloud platform.
Okay, any question? This is the first team's presentation. And anyone can say, if you have a question, you can raise your hand or give the message.
May I ask a question?
Okay.
Okay. This is Amir from Nottingham Trent University in the UK. I enjoyed your presentation, but I think in this 5 minutes, I couldn't get exactly what was your learning method for the knowledge base and rule base. Could you please have an iteration on that for me, please?
Okay. Hello, I'm a teacher. I'm an Yilin Cai, and let me answer your questions. And
Thank you.
for in this computation, we have the 5 different methods. So the first is FML machine learning tool, learning by the genetic algorithm. And the second is we use the XG boosting. And the third model is DNN, deep neural network. And the 5th model is FUZZ. The FUZZ is about the adaptive network-based fuzzy inference system. And the last model is FUZZ and the patch learning mechanism. So
yes.
In our experiments, we find that the FUZZ and the patch learning mechanism is outperforms other models. So in our fuzzy inference system, we have the 64 rules and the 6 inputs, six inputs for our fuzzy variable. Okay, and we use the Gaussian membership function to be our calculate our membership degree. Okay.
Yes.
And we have the single outputs for our inference system. Yeah, that's right.
Yes. Okay. So the main learning method that you used was FUZZ. Yes.
Hello, can you hear me?
Yes, I can. Yes.
Okay, we use the FUZZ and the patch learning mechanism. And the FUZZ we use the PyTorch to implement our fuzzy inference model. Yeah.
Yes.
I have a follow-up
Okay,
question.
good. Thank you.
Okay, thank you.
Can I ask a follow-up question? So the 3 methods you tried was evolutionary, computation, FUZZ, and what was the third one?
Yeah, FUZZ.
What was the third one?
What is the third one?
You said you did evolutionary computation, FUZZ, and another approach.
Oh, another approach. We use the deep neural network, DNN, and another one is XG boost.
Okay. So you didn't try, so maybe I misunderstood your answer. You tried 3 different methods initially?
Yeah. But exactly it's for 4 different methods. And the 4th method is FML tool and
Okay.
machine learning by genetic algorithms.
Evolutionary computation, that's what I meant. My question is, the follow-up question is, why do you think the FUZZ outperformed the other methods? And do you think there was anything you could have done to the other methods to improve their performance?
Because I think the fuzzy inference is the traditional method for approach the better performance. But I think many people use the deep neural network to train their model. So I want to use the fuzzy inference system combines the DNN. So we use the Gaussian fuzzy membership function to be our active function. So it can be the do some back propagation. So our model can training Gaussian function have the 2 different parameters. The first one is mean
the Gaussian of mean, and the second parameter is variance. So this model, the MFIS model can learn the mean and the variance. So I think this is better than the traditional fuzz inference system, because the traditional inference system, many people use the traploid shape or triangular shape. This membership function can do back propagation. So I think the back propagation is our better model for propose our goal. Yeah. Okay, my answer is get your question.
It was okay. I mean, it wasn't exactly what I was asking, but I like your answer. So, yep, that's fine.
Okay.